This is a video from section 2.1 in linear algebra. Let's take a look at problem 40. Prove the points x1, y1, x2, y2, and x3, y3 are collinear if and only if the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1 is 0. Now, let's make a note here. When I write an equal sign here, and I have an arrow that points to the right and an arrow that points to the left, this symbol means if and only if. And you might ask, well, what does that mean? When I write P if and only if Q, now keep in mind, P and Q are statements. Okay? And an example of a statement can be 2 plus 3 is 5. So when I say P if and only if Q, this means if P then Q, and at the same time, in other words, if Q then P. What does it mean for the points x1, y1, x2, y2, and x3, y3 to be collinear? What that means is that the slope of the line through the points x1, y1, and x2, y2 is the same as the slope of the line through the points x2, y2, and x3, y3. In other words, the one thing we can note is that y2 minus y1 divided by x2 minus x1 equals y3 minus y2 divided by x3 minus x2. These guys have to match, like so. Okay? Now, what we're going to do is we're going to start with the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1, and set it equal to 0. So remember, this is given. Now, by definition, this is true if and only if x1 times y2 minus y3 minus y1 times x2 minus x3 plus 1 times x2 y3 minus y2 x3 equals 0. So we're going to do this proof by a bit of a brute force method. Okay? Now, this is true if and only if. I'm going to distribute the x1 inside to each term here, and I'm going to distribute the minus y1 inside to each term over here. And so this is true if and only if x1 y2 minus x1 y3 minus y1 x2 plus y1 x3 plus x2 y3 minus y2 x3 equals 0 here. Now, notice how I underlined 3 terms. I'm going to keep those on the left side of the equal sign and move everything else to the other side. So, in other words, this is true if and only if x1 y2 minus x1 y3 plus x2 y3 equals y1 x2 minus y1 x3 plus y2 x3. So we're here. And we look at this and we go, well, what do we do with this, right? Now, I'll teach you something sneaky. If we go a little bit ahead, notice where I ultimately want to arrive, right? If I cross multiply, I get x3 minus x2 times y2 minus y1 is equal to x2 minus x1 times y3 minus y2. Does that make sense? So I'm trying to arrive at this conclusion. So notice how I start at the top and work my way down. It's a really interesting proof technique. Now I have a conclusion down here. And so I want to string together a few equivalences until I meet somewhere in the middle or close to the middle. So I go from top down and then from bottom up. I hope that makes sense. So if you notice, I'm trying to arrive at this conclusion, because if I can arrive at this conclusion, that means I can show that the 3 points are collinear by a string of equivalent statements. So now, x3 minus x2 times y2 minus y1 is the same as x2 minus x1 times y3 minus y2. Now, when I FOIL this out, okay, I'm going to FOIL out the left side, I'm going to FOIL out the right side. And if you notice, I picked up an extra x2, y2 right here, minus x2, y2. So when I come over here, if you notice, and it's not an accident, when I get to this line, notice what happens. I get x1, y2 minus x2, y2 minus x1, y3 plus x2, y3. So I have this extra x2, y2 here. But if I do it to the left side, I got to do it to the right side. And so I get equals y1, x2 minus x2, y2 minus y1, x3 plus y2, x3. And then what I did for the last line, if and only if, right? I factor by grouping, basically. So I take out a negative y2 and I multiply by x2 minus x1. And then I go plus, take out a y3 and multiply by x2 minus x1. So it's real sneaky. And I'm going to set this equal to negative x2 times y2 minus y1 plus x3 times y2 minus y1. I hope that makes sense. The most important part of this proof is going from here to here. And the reason why that's important is because if we're not sure what to do with a certain line and we know the conclusion we want to arrive at, start at the conclusion and work your way up some, and it might give you insight on how to proceed. So this is true if and only if x2 minus x1 times y3 minus y2 is equal to y2 minus y1 times x3 minus x2. This is true if and only if y3 minus y2 over x3 minus x2 equals y2 minus y1 over x2 minus x1. And this is true if and only if the 3 points x1, y1, x2, y2, x3, y3, all 3 points are collinear. And that'll conclude this video for section 2.1, and we did problem 40. And this is a bit of a brute force method. So, okay, thank you.